Hey everyone, here's a DYNAKIT Stereo 70 that I got from my friend Mike, who got it from his brother Pat. Thanks Mike, thanks Pat. I don't know how long it's been in storage or how it was stored. The only saving grace that allowed this amplifier to survive is the fact that there is no power cord. It is chopped off and broken at the base. It's pretty safe to assume that if you would plug something like this in, the magic smoke would come out, that which makes it work, and it would never work again. But what I wanted to do was open it up and have a look. I'm going to add on to this video how it was stored and for how long, give everybody a good look of what we're dealing with. The plan is obviously to remove the tubes, take a look at the performance of the power transformer and bring that up slowly on a variac. I don't expect the filter capacitors to fare any better than any other capacitor did in this unit. So this is the first time we're going to open it up. Oh, it is rough. Here's what we're looking at. We got about a couple of millimeters of dust. It seems to be populated with all the tubes. And these should be EL34s. I see a Amperex. This is a Sylvania. I've seen a lot of these with Sylvanias in them. This one, I don't believe I could see the name. And what else we got here? We got our complement 7199s. Should be a GZ rectifier. So what I'm going to do first is I'm going to pull out these tubes and take a look at them. This thing is definitely worse for wear. And take a look at these transformers. When I had got mine, the transformers had also rusted, and I had taken them apart and cleaned them and repainted them. But we got our grid bias right here, and the grid bias was for the channel, not for the tube, so it was not entirely accurate. We got a multi-core condenser here that has I believe 130 and 320 microfarad capacitors in that can. And those are generally gone. I don't even really bother trying to save those. Got our output transformers for left and right channel. It works in complement with this EL34 push-pull configuration. And let's take the tubes out and have a look and see what we got. I've got the tubes all cleaned up. Unfortunately, the paint was not standing up to the test of time, and a lot of these tubes simply lost the paint as they were cleaned, even with an extremely mild solvent. But you can see that within the tube, I mean, and they really cleaned up nicely, that it really stands the test of time. As for the characteristics of these tubes and the linearity, whether there's a short or not, yeah, I don't know. Some labels just came out perfect, like they were not affected. The 7199s right there, they're like hen's teeth. So we have our 7199s up top. Our GZ34 is our rectifier for DC, and then we have our 4 EL34 for the push-pull, 2 for each transformer. And we take a look at this, and what I'm going to do is I'm going to use the vacuum and brush method to see what comes off of this thing. Given the board a proper once over, I've also removed the top and bottom case. You can see that there's a lot of rust on the metal. A kind of restoration for this would definitely be one that was painted, because for rechroming costs you could actually get this chassis brand new from Dynakit. The important question is the output transformers and the power transformer. Now these may look bad, but I've often seen them look like this, and they do stand up. They can be cleaned and then repainted just like new. Obviously that would not be replaced. However, if you were going for something like this sort of effect, you could put the leave that can there after it was cleaned, because it's aluminum, so it will polish right up. And you would put the new capacitors under there. Capacitors have gotten much smaller since then. But here's how it looks without the tubes. There's the tubes right there. The bottom is kind of frozen in time because it doesn't look nearly as bad as what the top looked like. There's our choke right there. Looks like it's seen a lot of heat, a lot of sort of attic garage door kind of heat. We'd have to see how that choke was doing. That's an easy test. We can see the wiring is very nice condition. This circuit board, which I believe back then were still like, it would be like fiberglass, except they used paper, and it was layers of paper and some sort of resin. This is original Dynaco board. And as we look down here, we see here's the pots for the grid bias, as well as our capacitor. And here is the filter capacitors. These are the ones that always scare me, because these are the ones that cause a lot of issues. If they break down and short out, it's never a good thing. We have our output terminals directly above. These are the output transformers for your various types of speakers. 8 ohm, I believe it's 8, 16, and 32. I may be wrong. And all of the sockets. You'll notice that on this model, this original model, we have a cable tying this tube socket to this tube socket with a 15.6 ohm within 1% resistor. You can see the same thing on this side as well. And this was to set up the bias at the time. Would give you 1.56 volts, which was a really nice reference source for a brand new battery. I don't do this anymore. I removed that connection and put on 10 ohm resistors on each one. So I'm able to actually see, because I wire the second one to another port on here, and actually able to see how much current or would be going through these tubes to setting the bias properly. Also, right here in the middle, I see it looks like a selenium rectifier. I mean, on mine, I really haven't seen something like that in a long time. I got rid of that a long time ago. I have the updated board. But yeah, that's pretty cool. That looks like selenium rectifier, so we're going to have to test that out too. The mono stereo switch is broken. It is detached from the board, but that looks like something that could be easily repaired if need be. So there we have it. I decided to test the that grid bias capacitor. That's a 15.6 ohm within 1% tolerance. And I should tell you that these probes with these alligator clips cause 1 ohm impedance to be registered. So everything that I do, I have to subtract 1 ohm from. And I'm reading 16.5 right here. So it's actually a 15.5 ohm resistor after all of these years. I thought that was pretty cool. We'll see what the other one is. The other one as well on this side, 15.6 is showing 16.5 minus 1 is 15.5 ohms. So that's pretty cool. Those resistors are still not only within tolerance, but pretty much exact where they should be. I'll be testing other components to see what we have going on here. So after I first checked those 2 resistors, I decided to just proceed and check every resistor on the board under here, at least under the unit. And sure enough, every single resistor is in specification. I was quite astonished, even though that it doesn't say a lot with regard to how they would operate with heat or under load or whatever. It tells me that there was no catastrophic event that caused any serious problems on this unit. It didn't blow up and then stop being used. So what I'm going to do is I'm going to check the capacitors and see what kind of reading that I get in circuit. Maybe I'll plug the ESR meter onto it and see what happens. Testing the lower capacitor, and I realize I'm doing it in circuit, but I just wanted to have a look. It's a 50 microfarad capacitor, and it's registering 58, which would be pretty interesting if it was. However, a direct connection to the top capacitor yields 11 microfarads. So I don't know if it could be tested in circuit just like this. So maybe it's time to break out the ESR meter and see what we got going on. Breaking out the ESR meter, we see that The bottom capacitor has an equivalent series resistance of 0.5 ohms, which isn't exactly terrible. But I mean, we're just trying to get a reading of something that we really would never want to use. But just for comparison, I'll move it to the top one where we'll be getting that low capacitance reading from our test set. And when I plug it in, we'll see that we got 102 ohms of equivalent series resistance. So that capacitor is just asking for a serious problem. Under that kind of resistance, it could, the ESR, we're looking at something that's completely failed at this point. Like I said, as expected, 50 microfarad capacitors are a dime a dozen. And because we could probably do better than that, we could probably put in a greater size capacitor with a higher voltage rating than 75 volts for this unit. So the capacitors are something we definitely want to look at with regard to replacement. Lastly, I was able to measure the choke. This choke right here, coming off to the capacitor, is showing 0.87 microhenries. When testing it on the for resistance, which I'll just swap to on this meter. I believe I can. I believe it was 65 ohms. Yep, this meter is a little different. This one is showing about 67 ohms, give or take. So the choke is still good as far as electrical readings. The next thing I wanted to do was make sure the tubes were good. And I have my Sentry tube tester that I got from Uncle Kenny about 1,000,000 years ago. And while a tester like this won't tell you about really the characteristics or the linearity of the vacuum tube, well, it will tell you some important stuff with regard to repair. And the most important things are gas and short. A short is a no-go. If you have a short on your tube tester, then you know that if you put the tube in circuit, something terrible is going to happen. And it's interesting to note, like I said, I don't know how long that these tubes have been, sitting, doing nothing, but it's interesting to see after all these years, lighting back up. But what we can do with this tester, after that we verify that there's no short, and I've already checked the voltages on this tester, I use it regularly. I believe it's 6.3 volts for this socket. Is we're going to hit the quality button after we get our line adjust just right. So we could set up our line adjust. And then we hit the quality button, and it'll give us an idea of the emission of the tube. And this one is literally off the charts. So as far as just knowing the emission based on a single parameter about this tube at a certain amount of, I imagine a certain amount of bias with a certain amount of current that this meter measures. I don't know if it's actually measuring transconductance or what, but whatever it's measuring it good. So I'm going to do the rest of the tubes like this and see what we get. No matter how often you test the tubes, you really want to make sure that you follow the parameters that are explained in the manual. So I always have the manual open. For our purposes, we're working with an EL34. And we can see right over here that an EL34 is selector D, 32 and 3. So I have it on selector D. I have the voltage set up for, the load set up for 32. And then I got it in socket 3. So we test the next tube. And we see that this one is off the charts as well. So I'm going to keep going through and testing everything. I found that some tubes like this one took a long time to start showing good emissions on the scale. This is probably indicative of a tube that's weaker on the way out. But something I've also noticed with this tester is that if I keep running current through it, the condition will improve, almost like that somehow the characteristics of the tube work better. I'm not really sure, but now at this point, if I hold the button down, you can see it bounced up to 93 and then slowly makes its way towards 100. And as I sit there and give it some time and run the test, and whatever goes through it, whatever kind of current is going through it, seems to clear up the tube from a performance aspect. So what I'm going to do with this tube is I'm going to keep doing this till I get this 100 reading like you see, and then give it a break. But most importantly, I'm going to let it cool back down and see if the rise is back to normal or if it still has a really slow rise. If it has a really slow rise, there's really nothing we can do about that. Here we have one of our 7199s on the tester. And this one seems to have a good emission. I initially noticed when I plugged it in that the gas and short light turned on but then turned off, and it may be the circuitry of this unit. So what I'm going to do is I'm going to call this good, but I'm going to put it aside, and it's going to be retested just like that EL34 right there. So I'm going to proceed to the next 7199. And you can see the gas and the short light turned on this tube, just like the other one. But I'm going to give it a minute, since it's on the tester, and see what happens with this. Let it warm up, and see if this is just an indication of the tester. If not, then the 7199 is simply bad. So going back to this EL34, this one just seems to have a much longer heat up time. However, if I leave it alone and not put it under any load on the unit, what I see is I get about, let's see, 90 right off the bat. So I imagine this tube is okay. It's going to take longer to heat up than the others. So we'll test the rectifier. So far it looks like we have one bad 7199 that I'd really like to check with an ohm meter to see if I really do have a short somewhere. This tube is checked somewhat differently. It has to be checked on two different parts of the test set to check both circuits within the tube, which I already have set up on C and 50. So I'm going to put it in slot number 4 first and check the first half of the tube. And we'll see what we get. The first half of this tube is off the chart and rather quickly. So there's no need to further test that. There's no shorts and no leaks. So what I want to do is now take that and put it on the second portion of the circuit in slot 5. And it shouldn't take too long because the tube is already heated up right back on the heater. And we see that that is also, for our purposes, there's no need to check any further. So I can go back to the 7199s one more time and see what we got going on. Here's another reason why I use these tube testers. I would like to have one of those, what are they called, micro tracers for the characteristics. But basically what we have is a 7199 that if you were to read on a continuity meter, shows that there's nothing wrong with regard to a short. And when I plug it in, it won't show a short, but as it starts to heat up inside the tube, that is when the short appears. As you'll see right now, as I put it in socket 18, we'll look at the gauges here. And we'll just watch them as the tube starts to turn on. And you can see there's our gas slowly turning on. And then you can see there's the short light slowly turning on as well. This is a tube we're not going to risk. We're just going to let this one go.